So in the second section from chapter 5, we're actually going to be using a lot of the same skills we used in the first section, but in some ways it'll be easier because the idea is that you'll have both sides of the equation given to you, and one side you're going to be working on using the identities and performing whatever substitutions and simplification steps you can, and the other side of the equation is going to be what you're working towards. So it's kind of like I'm saying simplify the expression, but now you know where I want you to stop or what I want you to aim for. Couple comments about when you're working on these proofs. The proof will begin with the expression on one side of the equal symbol. So try to just work on one side of it, and then the other side is going to be what has the answer that you're working towards. So ideally, you will not have to touch the other side of the equation at all. There are some exceptions to that, but for the most part, only work on one side of the equation. The proof in between is just going to be you showing the steps from one to the next, like what substitutions did you perform, what kind of distribution properties or factoring did you do. You don't have to label the things. You don't have to actually write out like you do in the geometry proofs, but it needs to be very clear what you did from one step to the next. So don't try to do too much at once. So here's an example. I'm going to take this tangent x plus cotangent x, and I'm going to try to turn it into secant x times cosecant x. It helps to have a plan of some sort in mind. For example, I'm noticing that this originally had two different terms in it, and we're going to end up with one term of things being multiplied together. So I know at some point I need to find a way to combine these into one function, which is usually done through the trig identities or from somehow making them into a fraction and combining them into one fraction. So the first thing I'm going to try here is rewriting tangent as sine over cosine, and then I'll do the same thing for the cotangent. I'm going to rewrite that as cosine over sine. And then as you're working down, we're not really changing anything on the right-hand side of the equation, so you don't have to keep rewriting it over and over and over again. If you just write an equals sign as you're working down, if you don't actually write what's over there, then we're assuming that you didn't make any changes. And that's what I'd like you to do, is not make any changes to one side of the equation. So I'm just writing this equals, and I'm leaving that blank. Next, I have these two fractions, and I'd like to combine them into one, which would mean I want to get a common denominator on this. So I'm actually going to put a little more space in there so I can fill this next part in. So my next step would be that I want to multiply both the left fraction and the right fraction by something to give them a common denominator. On the left, I'm going to use sine of x, and on the right, I'm going to use cosine of x. So when you're multiplying fractions, go straight across. That means I have sine squared plus cosine squared on top. And I'm able to put these all into one fraction now because I got my common denominator of sine times cosine. Both of them have that same denominator. That's why I get to make it just one fraction at this point. So we're making progress. We've now got things down into one fraction, one term. Also look at your Pythagorean identities. You'll notice sine squared plus cosine squared is one of the more commonly used, one of the more important ones really, and that equals 1. And you could write this as two separate fractions if you wanted. You could think of it as 1 over sine of x times 1 over cosine of x. That would be fine if it would help you to see what I'm going to do in this next step. But essentially I'm just recognizing that the reciprocal of sine is cosecant. So I could write cosecant in the numerator instead of sine in the bottom. And for cosine, the reciprocal is secant. So instead of writing cosine in the bottom, I could write secant in the numerator. So I'm just going to flip both of those over essentially and write this as cosecant of x times secant of x. And we're almost done. The last step to make it match what we have is to recognize that the order in multiplication does not matter. So I can flip the order of these two to write it as secant of x, cosecant of x. I know that might seem like a trivial step to a lot of you guys, but it really is important that we recognize when something is and when it is not commutative, because sometimes you can't just switch the order, for example, with subtraction. So it is important that I show in this case, it's all right for me to just switch the order of the secant and the cosecant, and now it matches my answer perfectly, so we're done. Some other general guidelines to keep in mind while you're working on these. You will usually find more success if you start with a more complicated looking side and work towards the less complicated side. So if one of the side has all kinds of fractions and different trig functions being combined, and the other side just has like a simple 2 times cosecant, then leave that 2 times cosecant as your goal and only working on the other side of the equation. Work with the uglier side. If you ever get to a point where you can't find a way to combine fractions, or you can't see any identities that might be applied, don't forget to change things into sines and cosines, and that will often make some things cancel out or open up some new options for you. And also, you always have the combining fractions option. That's what I used on that last example we just looked at. So sometimes you need to find a common denominator and combine them into one. So here's another example. I'm going to work with this stuff on the left-hand side because that looks a lot uglier to me. I've got two different fractions with different denominators being combined together, and I'm trying to make them equal this 2 cotangent cosecant. So first thing I'm going to try is, since I have two fractions, let's get a common denominator between them. So for the fraction on the left, I would multiply top and bottom by secant x plus 1. And for the fraction on the right, I would be multiplying this by secant x minus 1. So I'm going to distribute a positive 1 times secant x minus 1. And that would make my denominator secant x minus 1 times secant x plus 1. From my experience, I find that it's helpful not to distribute the denominator until there is nothing else you can do. Because sometimes, when you simplify terms on top of the fraction, you'll find that it cancels with one of your two factors down here. So I try to simplify all this stuff first and see if anything cancels, and then if it doesn't cancel out nicely, that's when I go back and I distribute the denominator. So up on top, I have secant of x plus secant of x, which is 2 secant of x. And the positive one and the negative one will actually cancel. So that's all I have on the numerator. Since that does not look like it's going to cancel anything from the bottom, I don't have like a 2 secant of x down here as one of my factors, I'm going to go ahead and distribute this and see if that'll help. So secant times secant is secant squared. Usually you need to do the outside and the inside product, but when your two binomials are conjugates of each other, so it's the same term, secant and 1, but one of them has a positive and one of them has a negative, then the outside and the inside products will cancel if you're thinking of that in terms of FOIL. So the last thing I have to do is the negative 1 times positive 1. Now if you look at the third Pythagorean identity we have, this secant squared minus 1, we can manipulate the third identity to say that that is equal to tangent squared. Now try to make a habit of continuously looking at what your target is and seeing if you can kind of lock in place any of the pieces of it. For example, we have a 2 being multiplied by something, so I can kind of pull that aside and stop changing it and just ignore it. I also see that I have tangent squared in the denominator, which I know is the reciprocal of cotangent. So I could take one of those and flip that over to the top, and that would give me this cotangent of x in the numerator. So I'm going to kind of set that stuff aside as 2 cotangent of x. And then what I'm still interested in is the secant x over tangent x. So now it's like I'm just focusing on that part, and I need to find a way to make secant x over tangent of x equal to cosecant of x. So I'm going to try changing this part only into sines and cosines. And if I'm using my keep change flip, I know that secant is the reciprocal of cosine. And I know that tangent is sine over cosine. Because I'm doing keep change flip, that would be multiplying by cosine over sine instead. Now that sets up the cosines canceling, so all I'm left with is 1 over sine, and if you remember the reciprocal of sine is cosecant, then that means you can flip cosecant into the numerator of your expression. And so now if you look at what we had originally, we were looking for 2 times cotangent times cosecant, and that's what I've gotten to, 2 times cotangent times cosecant. So like I said, keep looking at what you have and what you're working towards, because you might be able to set some of the pieces aside, and then that way you can just focus on a smaller part, which may simplify and make more apparent what you need to do next. So that's all for the notes today. Thank you guys.